This is Karan Alang. I'm a principal software engineer with 25 years of experience designing scalable distributed systems, cloud-native platforms, and AI-enabled solutions. I lead the data engineering team at Versa Networks, where I architect real-time data pipelines and AI-powered automation frameworks. I'm a senior member of IEEE, a Forbes Technology Council member, a distinguished fellow of SCRS. I'm an open source contributor, mentor, and speaker at industry events on data engineering, data science, and AI. So the topic that I'm going to present today is called Automatic Threat Intelligence with Airflow, XDR, and LLMs using the MITRE ATT&CK framework. Quick disclaimer, this presentation reflects my independent research and is separate from my work at my employer. So let's look at the session outline. We'll look at the introduction. Why are we talking about this problem? We'll set the stage for the modern SOC challenges. SOC stands for Security Operations Center. If we look at the background and related works, we'll look at what MITRE ATT&CK is, what is XDR, what is LLMs in cybersecurity. We'll look at Airflow as well. We'll look at the proposed solution, the architectural overview, threat analysis with LLM integration of MITRE ATT&CK, and we'll look at the data processing pipeline with Airflow. We'll look at case study, the experimental setup, validation and testing framework, analysis, as well as results. Then we'll look at the future research directions. Finally, we'll look at the conclusion and the references. So why are we talking about this problem? Essentially, the security operations centers, they face an unprecedented crisis that threatens organizational cybersecurity resilience and analyst well-being. Right? There's an alert overload. Nowadays, they receive 10,000 plus alerts per day, which creates alert fatigue, and essentially means that the security teams miss out the critical threats. They're so busy looking at all these alerts that they're not able to figure out the critical threats which are hidden in the noise, the 10,000 plus alerts per day. What compounds the problem is there's a staggering 3.4 million cybersecurity workforce shortage, which essentially means that they're handicapped even more and again tend to miss the critical threats hidden in the noise. The legacy detection methods, the traditional manual and signature-based detection methods, are very slow, limited, and cannot keep up with the modern, rapidly evolving attack vectors. Then the manual mapping does not help either. Mapping the security events to MITRE ATT&CK TTPs provides immense value. But again, it is very labor-intensive and extremely difficult to scale effectively. So what are we proposing? We're proposing that we integrate Airflow, XDR, and LLMs for smart security automation. There has been some effort towards integrating some of these components, but a holistic framework combining orchestration, visibility, and AI-powered analysis for end-to-end threat intelligence has not materialized so far. We are trying to fill in that gap. The architecture itself is a modular AI-driven pipeline. We are going to use Airflow for orchestration. It is essentially the backbone and orchestrating complex workflows for alert ingestion, correlation, enrichment, and analysis. We're going to use LLM intelligence, essentially to summarize unstructured security logs and intelligently map them to MITRE ATT&CK's TTPs. We'll look at MITRE ATT&CK and TTPs a little bit later in the next few slides. We are also going to be using XDR visibility. XDR stands for Extended Detection and Response, and that ensures comprehensive cross-domain visibility with rich contextual enrichment across all the security layers. And we'll look at XDR in detail in the next few slides. We have a case study which we will go through, and we'll see how we are able to achieve higher detection accuracy and lower response time. Let's look at MITRE ATT&CK framework. What is it? Essentially, it is a globally recognized knowledge base that has revolutionized how security teams understand and defend against cyber threats. It has a common language which is called TTPs, and that essentially means tactics, the why of how the attacks are being done, the techniques, how the attacks are, what are techniques by which these hackers or attackers plan these attacks, and the sub-techniques of the procedures, which are the specific methods. This knowledge, this common language and this knowledge provides the defenders worldwide with a unified vocabulary. It helps them defend against the different cybersecurity attack methods. There's a huge industry adoption for the MITRE ATT&CK framework, and this is adopted across critical sectors, including finance, healthcare, and critical infrastructure. It is the de facto standard for threat modeling. It enables enhanced detection, okay, ensures that threat detection and mitigation capability, especially when integrated with modern AI, ML, and XDR, EDR systems. There is, of course, challenge in adopting this framework. While the adoption is there, right? Many of the organizations are not really confident in detecting the documented techniques, primarily due to tool incompatibility and difficulty of accurately mapping event data to TDPs, which, like I mentioned earlier, is a manual task and essentially results in organizations not being very confident about detecting these documented techniques. What is XDR? This is the key part of the entire architecture. It stands for Extended Detection and Response. What does it do? Essentially, it is the next evolution in security platforms, unifying fragmented security data into a single intelligent defense system. It provides unified visibility. It seamlessly unifies data across endpoints, networks, cloud environments, and email infrastructure. If you note, these are the different ways in which we access data. And because we started using things like cloud computing, networks, endpoints, email infrastructure, so much more in this current scenario, the attack surface has increased, has become much larger. Right? XDR also provides intelligent analysis. Essentially, that means that it delivers cross-domain visibility, analytics-driven detection, and automated response capabilities. That is the key. Okay. XDR provides automated response capabilities that can adapt to emerging threats in real time. It goes beyond SIEM. SIEM is nothing but security information and event management. It provides centralized visibility and correlation. It goes beyond other tools like EDR, which is nothing but endpoint detection and response, and SOAR, which is security orchestration, automation, and response. Okay, so it provides a lot of value. The key benefits being reduces alert noise and configuration overhead. It delivers faster, more actionable insights, and it integrates threat intelligence for richer investigations. So the key parts of this entire architecture, we'll look at it in more details in the next few slides. Let's look up LLMs in cybersecurity. This is probably the most novel part of the entire architecture. We all are familiar with LLMs now for the last couple of years. It is being used in many industries, and cybersecurity is no exception. So how does it help transform cybersecurity? It essentially transforms cybersecurity from being a reactive manual analysis to proactive intelligent automation at unprecedented scale. How does it do that? Basically helps in unstructured data processing. Okay, it processes complex unstructured security data, including logs, incident reports, and threat intelligence feeds. It does summarization. Okay, it can summarize alerts, extract indicators of compromise. What is IOC or indicators of compromise? These are essentially digital fingerprints left behind by attackers, clues that security teams can use to detect, track, and block malicious activities. There's something called IOE also, which essentially means indicators of attack. Okay, that essentially tells the SOC teams that your system is going to get attacked. IOC says that the system is already under attack. LLMs can help in rule automation as well, right? As I mentioned earlier, creating the rules is very manual, right? So LLMs can help enable automatic detection, rule generation, dramatically reducing analyst workload from hours to minutes for the rule creation and refinement. So LLMs, like I mentioned earlier, is something that we are proposing, and it is a novel change in the architecture. How do we ensure that the LLMs are doing the job effectively? Because as you all know, they can tend to do hallucinations. So what we do is we want to make sure that we use the prompt engineering best practices. We use techniques like few-shot learning, techniques like chain of thought, and guardrails, especially guardrail primarily because that helps implement validation layers to reduce hallucinations and prevent false or misleading outputs. Obviously, LLMs represent transformative step towards intelligent, scalable SOC automation that augments human expertise. Right? Look at the architecture, essentially the workflow. The first stage is data collection. It is a modular design. Okay, so the first part of the architecture is data collection. We are collecting logs, events, alerts from different endpoints, networks, cloud. We mentioned that in the last few slides. Then we do the analysis, the threat detection, anomaly detection, risk assessment using tools like SIAM, ADR, SIR tools, and LLMs, of course. We do the orchestration, which includes automated response, instant playbooks, mitigation actions using the SOAR playbooks. We do visualization finally, dashboards, reports, threat maps, dashboard and reporting tools. And as you can see from the diagram, essentially there's a feedback loop from the visualization layer as well as the orchestration layer to the analysis part. That essentially means that as threats change, as the different cyber security attack vectors change, right? Your architecture is actually self-healing and able to handle all these changing cyber attack threats. So it is a modular design, like I mentioned, and we use Airflow as a central orchestration layer. It ensures reliable, reproducible workflows with comprehensive monitoring. That's one of the reasons why we are using Apache Airflow. It uses XDR, of course. We mentioned that. It essentially ensures that we have unified alert gathering from endpoints, networks, and cloud infrastructure. Now, the LLM analysis layer, which is a key part of the entire architecture, it transforms unstructured alerts into actionable intelligence, summarizes security events, and maps them to MITRE ATT&CK TDPs, and feeds enriched insights directly into visualization response layers. Okay, so LLM, again, I'm just highlighting that because that is one of the key parts of the architecture, apart from XDR and the MITRE ATT&CK, of course. Let's look at how LLM integration helps in threat analysis. So the key parts are alert summarization, right? It automates conversion of raw logs into human-readable insights and narratives. It does entity and TTP extraction. Essentially, it uses similarity-based mapping to identify tactics, techniques, and procedures. Remember, TTPs is essentially the whys, hows, and the sub-methods of the MITRE attacks or the attack vectors, essentially, right? It does cognitive load reduction, dramatically reduces analyst triage time and decision fatigue, primarily because we're using LLMs with XDRs and other cybersecurity tools. Accuracy enhancement essentially increases consistency and precision in threat interpretation across all alerts. Primarily because everything is automated, and so even if the security attack volume increases, because it is automated using LLMs, we are able to make sure the accuracy is enhanced, right? So this is how we do threat analysis through LLM integration. Now, this is an interesting slide. What it shows is how LLMs actually help do anomaly detection, attack-informed anomaly detection. If you look at the blue line, right, those are that is the data that comes in, right? There is a dotted red line, which is the detection threshold. So when the activity actually goes beyond the detection threshold, the LLM is able to highlight that and figure out that it is an anomaly. It is able to identify what kind of anomaly it is. For example, it could be credential access, which means that unauthorized credential retrieval or password dumping has happened. It could be privilege escalation, for example. So that essentially means that attacker has gained higher level privilege. It could be lateral movement, which means that attacker has moved across systems within the network. So it is not localized, but moving to different systems, right? Which is a higher level of attack. And finally, it could be exfiltration as well, which is the highest spike, which represents data being stolen or sent out of the network. Essentially, this shows how LLMs are used to identify MITRE ATT&CK informed anomalies, right, which shows attacker behavior. Key slide in identifying how we are using LLMs in this particular architecture. So LLM integration of security analysis, another important slide. What it shows is we are going to be using a hybrid LLM strategy. And why do we do that? Essentially because a lot of the organizations do not want their sensitive data to be stored in the cloud. So we're going to use GPT-4 for general insights and Llama 2 for sensitive data insights analysis, right? We're going to use purpose-built prompts. Okay, these are custom templates for incident summaries, attack mapping, and report generation, and enforces consistent, structured, and actionable responses, right? We're going to have confidence-driven safety. Essentially, that means that every output is tagged with confidence stores. So, low confidence results trigger human review. So if you look at the diagram that says when you have low confidence results, that would trigger human review. Essentially, it means that there's a human in the loop component, which is part of this particular architecture. That ensures trust and reliability, especially when it comes to critical decision, right? So you have cloud-hosted LLMs. We have locally hosted LLMs, example, Llama 2 for sensitive data. You have human analyst review, and then you have augmenting analysis. So LLMs handle large data triage while analysts focus on strategic analysis. The whole objective of all this, of this particular architecture is to make sure that the data triaging, the mapping of security events to MITRE ATT&CK TTPs is handled by the system. And the analysts, they can focus on strategic analysis instead of being overloaded with alert fatigue and stuff like that. Let's go to the next slide. Now, this slide essentially shows how we're going to use Apache Airflow. What are the different workflows that Airflow is being used to orchestrate? So you have alert ingestion, which is one of the workflows. The schedule every 5 minutes. Again, the schedule can be changed. Okay, it's indicative. In this case, we have a schedule of every 5 minutes for alert ingestion. You have log enrichment, which is trigger-based. LLM processing, again, trigger-based. Attack correlation mapping processing. Okay, schedule hourly, and there's a manual review involved over there. And finally, response orchestration, which is immediate. Essentially, you want to make sure that once you figure out there's an attack, you want to be able to provide a response as quickly as possible. So why are we using Airflow? Primarily because it is scalable, handles thousands of concurrent workflows, it is reproducible, consistent execution across environments, and finally, it is also monitored, real-time visibility and alerting. Very useful as a central control layer, seamlessly coordinating AI analysis, data collection, and response models into a unified security automation pipeline. Testing and validation framework. One of the key things of making sure that this architecture works effectively is to ensure that we have a proper testing and validation framework. It is not a one-time setup. It is a continuous feedback cycle, which ensures every automated response remains accurate, explainable, and unmeasurable, right? So how do we do that? We have integration in unit tests. We verify correctness between the Airflow orchestration, the LLM analysis, and XDR detection modules. We validate the LLM prompt accuracy, mapping logic, and response triggers at the component level, right? We have the adversary emulation exercises. We use known MITRE ATT&CK sequences to simulate real-world attacker behavior, evaluate the detection coverage, response efficacy across the full pipeline. We do red team stress testing. Essentially, that means that we conduct multi-stage attack scenarios to expose weak spots and edge cases. We measure system resilience using resiliency metrics. We'll look at that in more detail. Right. So what are the different metrics that we track? We track mean time to detect, MTTR, mean time to respond. We look at the coverage, attack technique, coverage. We look at the accuracy, essentially the false positive rate. This is an interesting slide. Again, we look at how we integrate MITRE ATT&CK for threat modeling. Right. As you can see, there's an adversarial simulation matrix. So these are different system components from where we get data. You have the endpoint, servers, networks, applications, Azure Cloud, GCP Cloud, right? All these are fed into the adversarial simulation matrix. What is that? It is essentially a structured framework that maps simulated attacker behaviors, the TTPs, to the MITRE ATT&CK matrix in order to test and validate an organization's defense, right? It is a testing blueprint. Okay. It also essentially figures out the risk surface, right? So the red one is a little bit more critical, and the rest of it is less critical. Finally, we get a resilience index, which is essentially a metric that measures an organization's ability to withstand, respond to, and recover from cyber attacks or disruption. So this is key to being able to test out the entire architecture. Essentially ensures that we are able to simulate the different and the cyber attack vectors and make sure that our architecture is resilient enough to be able to handle the different cyber attack vectors. Right? Let's look at the experimental setup. It is a controlled evaluation environment. So it evaluates the pipeline scalability. This particular environment, right, it processes a blend of anonymized and synthetic security alerts representative of a mid-sized organization. So it is about 2,000 users, 5,000 endpoints, and it approximates a real-world operational workload. It evaluates pipeline scalability, orchestration accuracy, and MITRE ATT&CK coverage. We talked about this previously. We're going to use Microsoft Defender XDR as the alert source, right? For orchestration, we use Apache Airflow and Kubernetes. We're going to use a hybrid approach, essentially, which means that we use Azure OpenAI GPT-4 on the cloud, and on-prem we'll use Llama 2, right? We're going to use knowledge graph mapping. There's something I've not talked about, but we'll look at it in more detail. Why do we use knowledge graph? Primarily because the knowledge graph or the graph DB, like Neo4j, represents not just raw data, but also the relationships between the different entities. Okay, it gives a holistic view of what is happening in the environment. Okay, we'll look at it in more details in the next slide, but it is an important part of the architecture. We're going to use Splunk ES as a seam and the Phantom as a SOAR, right? As I mentioned last time, same as security information and event management, and SOAR is security orchestration, automation, and response. Critical cybersecurity tools, they're part of the entire architecture. We have controlled automation, human approval, gates for every automated response, and that ensures safe execution, ethical compliance, and traceable actions, right? 2-month evaluation, continuous trial capturing cross-domain events and responses, collected metrics for detection speed, alert volume, and attack coverage, right? So that is what the experimental setup looks like. Let's look at the empirical results. Like I mentioned, we have MTTD as one of the metrics. Pre-implementation and post-implementation, there's a 68% reduction in the mean time to detect, which essentially MTTD actually means that it is a time between a malicious or suspicious activity occurs on an endpoint network and the moment we are actually able to raise an alert or detect, right? Then MTTR, the mean time to respond, between pre-implementation and post-implementation, there's a 63% reduction. Alert volume to analysts. So I mentioned earlier that they get close to 10,000 plus alerts a day. That is reduced to 3,200 per day. Okay, it's a 74% reduction, a huge reduction, and helps the SOC teams and analysts focus on ensuring that they're able to catch the critical threats rather than working, trying to understand the different alerts. The attack technique coverage, there's a 67% improvement. The false positive rates is a 44% reduction. So all in all, good metrics which show that the architecture is actually working as we desire. So this is a slide which gives a slightly different view of the difference between the manual threat intelligence and automated framework. Obviously, it means that there's reduced human workload primarily because it is automated, right? Because we're using XDR, we're using Airflow, we are using LLM analysis, we're using GraphDB correlation, we're using Soren, XDRs and ADRs essentially. The result is low effort, high efficiency. Prior to that, in the manual threat intelligence, there was high effort and low scalability. The results are essentially the same as we saw in the previous slide. I'll not go over them again. So this is a slide which is an important slide. It shows how the data is actually stored in the GraphDB. Okay, like I mentioned, it is not just data. The GraphDB, instead of keeping data in rows and columns, it stores them as nodes and edges, right? It provides situational awareness. In other words, it helps see the full picture of what's going on across your systems, users, and networks. So one can detect, understand, and respond to threats a lot more effectively, right? This is the data which is stored in a GraphDB like Neo4j, right? So what are the qualitative benefits? It reduces the analyst fatigue. We've talked about this earlier. It enables accelerated knowledge transfer, which essentially means that the automatically generated MITRE ATT&CK mapped reports can become training resources for junior analysts. It enhances situational awareness. Again, what that means is since Neo4j knowledge graph visualizes correlations between alerts, assets, and tactics, it essentially enables the SOC team to understand what is happening in the system. Operational intelligence loop, essentially that means that the correlation engine continuously enriches context and improves detection logic, right? So there's a feedback loop, and that essentially ensures that the raw telemetry is converted into institutional knowledge shared across teams and shifts, right? Business level impact, what it does is instead of treating a cybersecurity as a cost center, it converts that to a data-driven business function with measurable ROI. And why? How does it happen? Essentially, that means that happens because the attack-based coverage metrics provides quantifiable proof of security maturity, right? So it is now a data-driven business function with measurable ROI instead of it being just a cost center, right? So everything looks good, but again, there are limitations and challenges. Let's quickly go over them. So the first one is LLM accuracy and hallucination risk. LLMs are probabilistic, right? And they can still have hallucinations. Okay, and that is something we need to keep monitoring and ensure we have enough guardrails. Right? You have human in the loop dependence. Critical decisions still require analyst verification for each low confidence or ambiguous output. Full autonomy is obviously not yet feasible. It'll probably happen sometime in the future, but not yet. Data privacy and regulation concerns. Essentially, since we're using commercial LLM APIs and the cloud, that can pose security compliance risks, and therefore we have a hybrid model. Integration complexity. Of course, since we are integrating Airflow, XDR, same sort, and LLM, all that can run into complex integration. And of course, beyond that, we also need advanced DevSecOps expertise. So there's complexity involved over there. Coverage gaps in MITRE ATT&CK. Now, automated mapping cannot yet address novel or unpublished TTPs, right? So if TTPs have not been published for a novel attack, that still is a gap that needs to be addressed. Cost of ownership. Commercial LLMs and XDR licenses plus GPU resources, there is a total cost of operations. So that has to be kept in mind, has to be monitored. And we also need specialized personnel, which increases the long-term investment requirements. So these are limitations and challenges. Let's look at finally the future research directions. Now, the future research directions will not just address the current limitations, but also expand capabilities for autonomous, explainable, and collaborative defense. So what do we require? What will this include? The first one is specialized security LLMs. What that means is we need to develop domain-tuned models trained on curated threat intel reports, malware analysis, and attack data to reduce hallucinations, increase mapping precision. We have to use adaptive prompt engineering. Essentially, that means that we create self-learning prompts that evolve from analyst feedback and live campaign data, enabling context-aware reasoning that adapts as attacks change. Explainable AI for trust. Now, explainable AI is something which is very important for AI/ML, right, and LLMs, because that, in this specific case, moves beyond detection ID to provide natural language rationale for each inferred attack technique, and that helps build analyst confidence and satisfies audit requirements as well. Automated gap remediation. What that means is, instead of just detecting weaknesses in your security coverage, the system can also fix them automatically. So that is what automated gap remediation means. A key future research direction. Okay, privacy preserving collaboration. This is fairly important. What this essentially means that we have different organizations which can share threat intelligence and learn from each other's attacks, without ever exposing their private or sensitive data. A very important initiative, because as we work together, as the different organizations work together, that will help ensure that we learn from each other, and be a lot more effective in handling the different attack vectors. Right? Scalable evaluation framework. Essentially, that means we are trying to create a standardized, repeatable way to test and compare AI-driven security systems across different models, dataset, and attack scenarios. So the results are credible, measurable, and comparable at scale. Okay. So these are some of the future research directions that I think are fairly important. Finally, some of the references are listed out, not all of them, but these are some of the references that we looked at in this research. Thank you. That's all.